information management and information technology to manage nursing information. Information management is an integrated set of methodologies designed to create and operate the data-centered information system for an organization as a whole or for a significant part, such as a division or department, in order to support the information flow and the subsequent decision-making processes within the organization. Within information management, the system development lifecycle is the important process for developing information systems through a multi-step process from investigation of the initial requirement to analysis, design, implementation, and maintenance. There are many different models and methodologies for system development, but each generally consists of a series of well-defined steps or stages. System development nowadays is the result of the collaboration of multidisciplinary teams such as system engineers, analysts, programmers, testers, and end users to create the millions of lines of custom-written code that drive enterprises, including the healthcare enterprise. To manage this, a number of system development lifecycle models have been created. Some of them, and the best known, are the waterfall, fountain, spiral, build and fix, rapid prototype, incremental, and synchronize and stabilize model. Within each model, several stages can be characterized and divided up in different ways, including the following: project planning and feasibility study stage. This stage establishes a high-level view of the intended project and determines its outcomes and goals. System analysis and requirement definition stage. This stage includes a detailed study of the organizational needs. The needs are then mapped into a logical model, and that in turn is translated into a prototype of design. The system analysis and design stage may also consider options for changing the organizational processes, the workflow, and will also need to determine the appropriate hardware and system software to be used. The next stage is the system design. This stage describes the desired features and operations in detail, including screen layouts, organizational units, procedures, process diagrams, pseudocodes, and other documentation such as a data dictionary. During the implementation stage, the computer codes are developed and databases are designed. The integration and testing stage brings all the pieces together into a special testing environment to check for errors, bugs, and interoperability between the different modules. The following stage is the acceptance, installation, and deployment model. The final stage of the initial development, where the software is put into production and runs the actual organization. The next and last stage is the maintenance. In this stage, changes, corrections, and additions to the system are implemented, or a move to a different computer platform may be considered. Important in the information system lifecycle is the role of the user, not only in the specification of the requirement, but throughout and beyond the system development. Considerable feedback and interactive consulting with the user is imperative for success of the system. Also keep in mind that information systems do not start with re-engineering, but they are inherent to each organization. The best approach to reveal the information flow in an organization is to start modeling the organization. A model is a symbolic or abstract representation of the reality and the result of visualization of the structure. Within the information management, three types of models exist. They are the data model, the activity model, and the interaction model. Data models are the blueprints for the information systems. Data models depict data and the relationship between the data, enforcing organizational procedures and the policies for information flow. Activity models record the activities of interest, involve functional decomposition of the organizational processes from the highest level to the lowest, or the top-down model, as well as the specification of the process dependency events to refine the decomposition of the processes at each level. The last models are the interaction models. They define how the organizational activities or events affect things of interest to the unit's data flow. In the previous slide, the concept of data models, data flow diagram, activity models, interaction models, and decomposition diagrams were introduced. These models can be considered as precursors to database design. The goal of a database is to generate a set of schemas that allow us to store information without unnecessary redundancy or retrieve information easily and accurately. A database is a structured electronic collection of related data elements similar to a paper database, such as an address book or a telephone book or a Rolodex. Data in an electronic database are managed, stored, and retrieved by a software package or software system called a database management system. The next section will talk about the different types of database systems. They are the hierarchical database system, the network database system, and relational databases. The first type of database we are discussing are the hierarchical databases. This type of database is conceptualized as an upside-down tree in which the data elements are organized hierarchically. Relationships in a system are thought of in terms of children and parents, such that the child may only have one parent, but a parent can have multiple children. Parents and children are tied together by links or pointers, assuring that the data can be accessed systematically. Hierarchical databases were developed for older mainframes. Although redundancy is generally avoided for one-to-many relationships, redundancy in hierarchical databases will occur for many-to-many relationships, and it is mainly due to the effect that a child may have only one parent. The next type is the network database. This model was developed to solve the redundancy problem in hierarchical databases. Relationships are represented in terms of sets rather than in a hierarchy. In fact, a hierarchical model can be viewed as a subset of the network model. However, instead of using a single parent tree hierarchy, the network model uses sets to provide tree-like hierarchies, with the exception that the child tables were allowed to have more than one parent. This allowed the network model to support many-to-many relationships. The network database type has problems too. It's difficult to implement and maintain, and is rather a programmer tool than a real end-user system. The next type of databases are called relational databases. Relational databases were developed in the 1980s from the work done by Codd at IBM. This model was built on principles of Boolean algebra. At the core of a relational model is the concept of a table in which all data are stored. Each table is made up of records. This means the horizontal rows, also known as tuples, and fields, the vertical columns, also known as attributes. Tables in a relational database are linked through their relationships, one-to-many relationships. Data in a relational database are accessed on the values of the data, the records, and in addition, relational systems can use operations recursively in order to provide information about the database which facilitate their management. Relational databases are very popular because of their conceptual simplicity and their query language, SQL. For more complex and very large databases, this simplicity poses a problem in implementing the operations and specifying the semantics of the data. An object-oriented database has been designed to provide a solution to the issue. Related records are now grouped in an object, and associated with the object are methods for entering and maintaining fields within the object. Within the object, very specific and related elements are grouped in classes. The classes inherit attributes from the object, example a vehicle, such as registration, number of wheels, cylinder, speed, and so on. But classes also have specific attributes that separate them from each other, such as a car is a vehicle that is designed for personal transportation and requires as thus a special license. A bus is also a vehicle, but that is designed for public transportation and has more stringent requirements for the license. As explained earlier, database planning begins with the specification of the information that is needed for managing the unit or organization. Next, we need to model the information and data currently available and in a detailed fashion. The models are then compared with the required information and data by internal and external procedures. Examples of data manipulation are sorting, querying, and in querying we have a simple query, a Boolean query, or a calculated query. A simple query is one word. A Boolean query looks up Virginia Henderson plus nursing theory. A calculated query is from if A and B exist, give me C. Another manipulation of a database is generating reports or lists, or generating forms, mostly for online data entry. Lastly, we will provide some examples of information system applications in healthcare. Information system applications in healthcare can be grouped as patient-centered information systems, medical nursing knowledge and decision support systems, and institutional information systems. Examples of patient-centered information systems are patient health records. These include the electronic medical record, the electronic health record, and the personal health record. The difference between each of those is that the electronic medical record is managed and owned by a physician, while the electronic health record is managed and owned by a healthcare institution, and the personal health record is managed and owned by a patient. Another example are primary care systems. They consist of a demographic, a medical, a pharmacy, financial, communication module to support healthcare delivery. And we have clinical departmental systems such as internal medicine, oncology, surgery, orthopedics, pediatrics, neurology, emergency care, based on the specific tasks of a unit. We also have clinical support systems used in ancillary clinical departments such as laboratory, medical imaging, and radiology. A well-known system is the PACS system that is used in radiology and medical imaging. We have also nursing information system to support nursing care and communication. Examples are the nursing documentation systems using a standardized nursing terminology such as NANA, NIC, NOC, ONHA, CCC, and even SNOMED CT. We have clinical and administrative nursing decision support systems such as CarePlan, CANDY, ORSS. The next group is the medical nursing knowledge and decision support systems. Examples are Internet, One, Prodigy, One, MUMS. All these systems are guidelines to support decision making and problem solving in clinical care. The last group is the institutional information systems. These information systems are based on models of public health and healthcare delivery. Examples are public health surveillance, hospital information systems for institutional use, but also health information resources, which are publicly available databases for healthcare institutions and consumer organizations. Examples are the World Health Organization, the National Library of Medicine, CDC, state institutions for healthcare, consumer organizations such as the National Cancer Institute, the Diabetes Organization, primary care physician organizations, and so many more.